All right, let's get right into it. If you've ever tried to take a cool AI demo and turn it into a real product, you probably know the feeling. It works perfectly for you, but the moment real users get their hands on it, everything just breaks. Today, we're going to talk about exactly why that happens, and we'll introduce a really powerful idea to fix it: AI harness engineering. It's all about moving past just fiddling with prompts and starting to build AI that's actually tough enough for the real world.
And this whole thing kicks off with a story that's probably going to sound very familiar if you've been building with AI. It's the classic tale of a perfect, shiny demo meeting the messy, unpredictable chaos of reality.
So, picture this. You've just built this incredible AI coding assistant. You show it off, you give it some code, ask it to find a bug, and bam, it nails it. The demo is a huge success. Everybody's excited. Stakeholders are patting you on the back. You feel like you're on top of the world. But then the real users show up. And, well, they don't use it the way you do. They paste in weird, messy code. They ask confusing questions. They push all the buttons you didn't expect them to. And just like that, the magic starts to fizzle out.
And what does that fizzling magic look like? Oh, it's painful. The AI suddenly forgets what you were talking about 2 sentences ago. It gives you a nice paragraph of text when your app is screaming for structured JSON. It calls the wrong tool, or even worse, it just gives up and crashes mid-task. It's a total nightmare.
So, your first instinct is probably to blame the model, right? We need a bigger model, a smarter one, but what if the model isn't actually the problem here? What if the real issue is everything you built or didn't build around it?
And this gets to the absolute heart of the problem for so many AI apps. We've all been trained to think that the answer to every problem is just to tweak the prompt. But as you're about to see, that strategy has some really serious limits. For building real products, it's a dead end.
Here's why just trying to prompt your way out of it doesn't work long term. First, prompts are super fragile. You change one word, and you can get a completely different result. That leads to inconsistent outputs, which is a killer because these models are not deterministic. They can fail in ways you would never expect. And here's the bottom line. Real systems, the ones people pay for, need to be reliable and predictable, even when the AI core is, anything but. Let me give you a classic example. You tell the model very clearly, return your answer as valid JSON. But what do you get back? A chatty sentence. And your application, which is expecting to parse a clean JSON object, just breaks. It throws an error, the whole thing crashes, the workflow is dead, not because the AI was wrong, but because you couldn't control its output.
So, this is the big takeaway. You could spend weeks, even months, trying to write the one perfect prompt that never ever fails, but you're going to be fighting a losing battle. The real solution is to stop obsessing over the prompt and start engineering a better system. And that brings us to the hero of our story, this idea of an AI harness. This is the engineering discipline that takes a powerful but kind of wild AI model and turns it into a reliable tool you can actually put in production.
So what is it exactly? Well, AI harness engineering is all about building the system around the model. Its whole job is to create structure, to enforce rules, and to make that AI reliable, controllable, and something you can actually observe and use in the real world.
Okay, here is the absolute best way to think about it. An LLM, like GPT-4, is like a massive, powerful jet engine. It's incredible, but an engine by itself is also really dangerous and totally useless. You wouldn't just strap yourself to it, right? The harness is everything else that makes a car a car. The steering wheel to tell it where to go, the brakes for safety, the dashboard so you know what's happening, and the seatbelt to protect you. The harness is what makes the engine useful. So at a high level, the flow looks something like this. The user's input doesn't just go straight to the LLM. No way. First, it goes through an inbound harness that cleans it up and gets it ready. Then, after the LLM does its thing, the response doesn't go straight back to the user either. It goes through an outbound harness that checks it, fixes it, and formats it. That way, the final output is exactly what our system needs it to be.
Okay, so this harness sounds cool, but what is it actually made of? Let's break it down into 7 specific layers of control that give us way more power over how the AI behaves. So the first 3 layers handle everything before the model even sees a request. First, input processing cleans up the user's messy query. Second, prompt construction uses smart templates to build the perfect prompt on the fly, instead of just using a static block of text. And third, routing. Think of this as the air traffic controller. It decides, does this task need a big, powerful model, or can we use a small, fast, cheap one? Or maybe it doesn't need an AI at all.
Now for the outbound side, This is where things get really cool. Layer 4 validation is mission critical. It checks the output. Is it valid JSON? Does it follow our rules? If not, Layer 5 retry and repair kicks in. It can automatically try again or even tell the model, hey, you messed that up, fix it. Layer 6 is memory, which stops the AI from having amnesia about the conversation. And finally, Layer 7 observability logs everything so we can actually see what's going on under the hood.
And that last layer is so important. Because if you can't see the prompts, if you don't know how the model is responding or why it's failing, you're flying completely blind. You just can't fix what you can't see. Observability is absolutely fundamental.
So let's put this all together now. How does this whole harness concept transform that brittle coding assistant from our story into a system that's actually ready for production? Okay, let's go back to our AI assistant, but this time it's been re-engineered. First, the system reads the code and detects what language it is. Then it routes the request to a specialized coding model with a structured prompt. When it gets a response, it validates the format. Then, and this is brilliant, it runs the code in a safe sandbox environment to see if it actually works. If the tests fail, the retry layer kicks in to try and fix it. Only after all of that does the final validated and tested answer go back to the user. See the difference? It's not just a prompt, it's an entire intelligent workflow. And this right here is the central idea. The real intelligence of a great AI product isn't just in the raw power of the LLM. It's in the thoughtful, carefully engineered workflow you build around it. That's where the real value and the reliability come from. So, if you're building an AI app, here are the traps you need to avoid. Don't try to solve everything with one giant complex prompt. Always define a clear schema for your outputs. You absolutely have to build in some kind of retry logic. Monitor everything. And for goodness sake, don't use your most expensive, powerful model for every single simple task. I love this quote because it is so painfully true. It is so easy to just tape up prompt to a user interface and call it an AI app. But that's a demo, that's a prototype. Real scalable AI products aren't just prompts, they are fully engineered systems. So that leaves us with the final question, and it's one you should really think about. Look at what you're building. Are you just taping a prompt to a UI and hoping for the best? Or are you actually engineering a robust system that's ready for the real world? Because that, right there, is the difference between a cool demo that dies and a product that lasts.